Hi and welcome to my session on the Data Platform Summit 2020. My name is Stropek and I'm looking forward to spend 60 minutes on the topic of privacy in the public cloud. Especially, I'm going to talk about private endpoints. Private endpoints are, in my opinion, a really great extension of the Microsoft Azure platform. Why? Because it enables you to use platform as a service and serverless storage offerings, especially Microsoft SQL Server and all the other great data platform services that Microsoft offers you, and you can turn off public internet access and put them into your virtual networks. We'll talk about the details, how that works, and that is the core topic of this session. Before I dive right into the topic, let me quickly introduce myself. My name is Stropek. I am a consultant and a software developer here from Austria in Europe. I have been a Microsoft Azure MVP, Microsoft Developer Technology MVP and Regional Director for quite a few years, and I have been using the Microsoft Azure platform for over 10 years. I help small, medium and large companies to transition into the public cloud, especially Microsoft Azure, to build architectures for software as a service solutions and, in general, answer questions that they have about the Azure platform and cloud computing in general. Before I talk with you about private endpoints, and approximately half of this session will be dedicated to a larger demo, I want to give you a little bit of context what private endpoints are really all about. And when I give you context about private endpoints, I need to talk about a concept which is called ZeroTrust Networking, because private endpoints has a lot to do with this concept of zero-trust networking. So before we go into the core topic of this talk, let's set the context and talk about this concept. In this diagram, you see the typical network architecture, which is still in place in many larger companies. You see here on the right-hand side, let me quickly draw a little bit. Here on the right-hand side, you see the typical local area network. You have all your precious servers like database servers and other servers. You have the clients, and maybe you have some subsidiaries where you have smaller servers and a bunch of additional clients, and they are connected via a virtual private network with your corporate network. When it comes to the internet, there is something special because the internet is not directly connected with all your servers and clients and so on. On the contrary, the internet is really very much separated from your local area network. Maybe you have here a demilitarized zone with some firewalls and proxies and so on, and this demilitarized zone, these firewalls, they are protecting the local area network from the internet. So the kind of viewpoint is that you have the big, bad internet out there, and inside our corporate network, we are all good friends. Everything is fine on the local area network. We have pretty hard rules outside, and we have soft or no rules inside. This concept has been called perimeter-based security because we have a strong network perimeter which protects our internal local area network from the outside internet. This perimeter security concept is characterized by the viewpoint that we have a secure inside and an insecure outside. We have a lot of proxies, a lot of firewalls. Firewalls are super important. We use virtual private networks. If, for instance, one of our employees would like to access a company's server, then this employee has to connect to a virtual private network in order to get virtually into the local area network of our company, and then he can access the database. Perimeter security nowadays has quite a lot of problems, and I just mentioned a few examples here to give you an idea. First, mobile and home working employees, they really have a problem when being outside of the corporate network, always having to use a VPN. That's not very convenient. Those employees might be used to systems like Office 365 or Gmail and so on, where it is super convenient to just take any device that they have at home and use just an internet connection to securely access their data. With perimeter security, that's much more inconvenient. The next problem is that nowadays, especially in larger organizations, the question is the company LAN really a fully secure network? That cannot be guaranteed. In many areas, there is no reason to assume that the company LAN is more secure than the internet. Last but not least, we have the concept of software as a service, which is really very present in nearly all organizations nowadays. Think of Office 365, think of a Dropbox for Business, think of many of the other software as a service solutions which exist out there on the internet. Your employees, they want to use them. They want to they will send traffic, network traffic, outgoing from their corporate network because they want to, for instance, access a software as a service solution. Could be also a database like Azure SQL database. But it's also a matter of incoming stuff. Think of, you have Power BI out there on the public internet, and your employee would like to use Power BI to access a database which sits on your local area network, which again is protected by perimeter security. That's a big problem. That means that you have to build some kind of gateway or proxy infrastructure in order to enable access from the software as a service solution to your database. Does that make your overall network architecture more secure? I doubt it. If you are interested, especially in this topic of perimeter security and why perimeter security is not state-of-the-art anymore, I encourage you to take a look at Google's Beyond Corp project. By the way, mentioning that, give me a second here. Here you see this link that I have in my slide deck. If you are interested in this slide and you would like to, for instance, follow this link, just note here this URL. Oops, sorry, wrong direction. Note this URL. Just type it in your browser. This will bring you to the online version of my slides, and in these slides you will find all these hyperlinks working, and you can take a look at the references that I make inside of this slide deck. Back to our topic. So, this was our previous network infrastructure. And with all the problems that I mentioned, we could consider changing it, flipping it upside down. We could say, no, we no longer trust the local area network and consider the internet untrustworthy. We just say we cannot trust any network. There is no secure network. All the systems that we run and that we build, all these systems, they have to be built in a way that they consider every incoming network request as untrustworthy. And with that, to a certain degree, we can see the internet or the extension of the internet in our local subsidiaries, for instance, as our corporate network. Everything is on the internet. Why not? We are used to that. We are used to Office 365. We are used to Power BI. We are used to many software as a service solutions out on the internet. We already do that. So can't we just take our, for instance, also our precious SQL servers and put them on the internet and access them over the public internet? Well, many companies that I know don't feel very comfortable doing that because they come from a very different age. They come from a very different viewpoint. So it is important that if you want to follow this zero-trust networking approach and you take this zero-trust networking approach and argue that you would like to run all your precious databases on the public internet, you have to follow a bunch of prerequisites. Otherwise, really bad things can happen. And I would like to talk about these things that you have to consider in the next few minutes. If you would like to go for a zero-trust networking approach, and with that argument you take your, in the past, servers which were run inside of your perimeter network and put them now on the public internet, you have to follow a bunch of rules. And there are, in general, 3 very important rules that you have to fulfill. The first one, authenticate every connection. So whenever somebody would like to access a certain system, for instance a database, this employee has to authenticate himself. Second, authenticate also devices. it's really important that you distinguish between, for instance, corporate devices, which fulfill certain standards and bring your own devices, maybe private devices of your users. So the authentication has two aspects here: the user and the device or location where the user uses his device. The second very important rule is encrypt all traffic. We need to encrypt everything, because if we don't trust any network, we cannot simply transmit unencrypted data. And the third rule is log everything. The question is not, will something happen at one point in time? The question is only, when will something happen on the long run? The second thing is that we have to consider is that in a zero-trust networking environment, we always work in a mode where we assume that there has been a breach. And we need to have the possibility to investigate that. We need to have the possibility to find out what happened in our network, for instance. And for that, obviously, we need logging. So log everything is a very important concept when it comes to zero-trust networking. You might argue, what about legacy apps? You might question, Rainer, what about my legacy app which has not been built for a zero-trust networking approach, which has not been built to run with a direct connection to the public internet? And you are very right. If you have such legacy apps, you shouldn't connect them directly to the internet. For instance, if you have a SQL server which is rather old and for various reasons you cannot update this SQL server, you should never connect it directly to the public internet. A system has to be built for running in the public internet in a zero-trust networking approach. A possibility to deal with legacy apps is network segmentation. So you create smaller segments. I'm not talking about the big perimeter security which spans your entire corporate network. No, I'm talking about much smaller smaller segments where your legacy apps are run. And there you might still have perimeter security. There's nothing bad about firewalls and things like that. But we structure them in a more fine granular way. So this is called micro-segmentation, and you will see in a few minutes that private endpoints are really a lot about micro-segmentation. A problem in that context are PaaS and serverless services, and this is exactly where we will need private endpoints in a minute. What is the problem here? Imagine that you have this legacy app and it needs to connect to a SQL Server database, for instance, but it cannot use, for instance, a modern authentication technology like Azure Active Directory. It still uses user and password and connection strings and so on, and you don't feel comfortable with exposing a SQL Server database where you still use SQL authentication and expose it on the public internet. You don't want to do that. You have this legacy app, but you also want to use Azure SQL Database, which is platform as a service. Your problem is that you cannot take Microsoft's SQL Azure database and put it into your microsegment, into your virtual network. That's not possible because you don't own the database server. The database server is run and owned by Microsoft. They run this huge farm of many Azure SQL databases in a multi-tenant fashion, and you only get a small part of this huge cluster, your database server and your databases for your app. You cannot rip that out and put it into your virtual network. That's not possible. Microsoft simply does not support that. So we need a solution for that. And exactly here, private endpoints really shine, and you will see that in a few minutes in the demo. Let's wait for another few minutes until we go into private endpoints, because to be honest, the most simple way is avoiding private endpoints at all and run all our systems directly connected to the public internet. But maybe you feel like this guy here, I need help if I want to run my applications and databases on the public internet. I cannot do that on my own. That would be way too risky. So good news is Azure can help. Azure has a lot of functionality which helps you to get ready for this zero trust networking approach. First, My first tip for you is always use platform as a service and serverless. Never use infrastructure as a service. Virtual machines are not your friend. Don't get me wrong, virtual machines in Azure are a great thing, and for many situations, you will probably use virtual machines even nowadays. But for new applications, for cloud-native applications, you should not use infrastructure as a service anymore. Just go towards PaaS and serverless. Let the platform manage your databases, your web clusters, your NoSQL databases, your blob storages. Don't build the systems on your own because that's super expensive and work intensive. And we don't want to do that. Let the topic of patching be the problem of the cloud provider like Microsoft. That is my first tip. And that frees a lot of resources on your side, and that's a good thing because if you have free resources, you can spend these resources on different areas, on different topics. Next thing, I had a tip where I said encrypt everything, and the good news is that Azure comes with encryption out of the box for data in transit and data at rest. So if you create platform as a service and serverless storage systems like Azure SQL Database, you do not need to care about encrypting this stuff. The data is encrypted automatically. On a web application level, you have the topic of certificates because maybe you have some custom domain names. You want to have this beautiful URL that your customer sees, and therefore you need to create certificates. And again, the good news is that nowadays Azure can manage these certificates even for your custom domain names out of the box. It's called Managed Certificates and it's available for free. Follow this link if you want to learn more. If you cannot avoid storing some kind of secrets, think of database connection strings or API keys and things like that, never store these things in your application config files. That is the wrong place. Use Azure Key Vault for certificates, for secrets, for database connection strings which contain secrets and so on. Because in Key Vault, everything is protected and everything is encrypted. The next one is a very important one. Avoid SQL authentication and in general shared secrets for authenticating to storage systems at all. Use Azure Active Directory. If you have a user who connects to your application or your SQL Server, for instance, then the user has to use a user from Azure Active Directory. Maybe the user already has an Office 365 user. Maybe he already has multi-factor authentication configured. That's a good thing. So let the user use his single sign-on credentials with multi-factor auth and things like that to connect to your database systems and your web applications and mobile apps and so on and so on. When it comes to machine-to-machine communication, you should again rely on Azure Active Directory. Never use some kind of keys or SQL Server authentication, passwords, things like that. Use a system which is called Managed Identities, which is really great in Azure. This Managed Identity is a fully managed set of credentials. You just deploy your software on Microsoft Azure, or you just use a virtual machine and there as a user you sign in with your single sign-on credentials and Managed Identities will do all the rest. Now we'll come to the core topic of our talk here, private endpoints. Use private endpoints to really lock down network segments. You should use private endpoints whenever you deploy something in Azure which does not need access from the public internet. Think of a SQL Server database, for instance. Think of a web application that uses a SQL Server database as its backend. Over the public internet, nobody should be able to use this SQL Server database. Why should we enable public internet access? Wouldn't it be better, although we have the zero trust policy, but still, wouldn't it be better to just deny public internet access? It gives us an additional layer of security. And this is exactly where private endpoints come in. And this is what I'm going to show you in the second half of this talk in an in-depth demo. Yeah, logging and monitoring, I already told that. And in Azure, use Application Insights and Azure Monitor for that. We have some additional things where Azure can help. When it comes to network security and when we want to build some isolated network segments, micro-segmentation, then Azure knows a lot of tricks. You have the so-called network security groups, NSGs, where you can exactly specify which network should be able to talk to whom. You have web application firewalls, you have DDoS protection, you have API management if you want to build a REST API, for instance. You have a secure service, the so-called Bastion service, for accessing your virtual machines, if you have some, via RDP and SSH without having to open these machines to the public internet. You can go through the Bastion service. Essentially, you're using a browser to access your RDP or SSH connection not directly from your developer box, but you use the browser, and from the browser on you are having a browser-based RDP or SSH service in Azure. And of course, VPN gateways, because if you have different subsidiaries and all these subsidiaries would like to connect to your isolated network segments, VPN gateways, managed VPN gateways in Azure are a great way of setting that up. Again, it's a PaaS service, so you don't need to manage it on your own. Large parts of the management is done by Microsoft. One thing that many people sometimes forget is that Azure has another big advantage when it comes to platform as a service and serverless. It gives you a secure control plane. I mean that you have a website, you have the Azure Portal, and with the Azure Portal you can configure your infrastructure, you can configure your services without having to open these services to the public internet. If you have a virtual machine, for instance, and you would like to configure some services running on this virtual machine, you have to somehow connect to this virtual machine. If you have a PaaS service, on the other hand, and this PaaS service is completely locked down, you cannot access it from outside your virtual network in Azure. There is no public internet access. You still can configure this service because you have the Azure Resource Manager, you have the Azure Portal, you have your Cloud Shell, you have PowerShell and things like that. And through this control plane, you can securely configure your PaaS and serverless services, and you do not need to open up public internet access just because you need to manage and configure these services. These were some tips, what you should do and where Azure can help. And there are also a few things that you should avoid, and I already mentioned some of them, so we will only quickly go through these. First, avoid secrets. I already told you the best solution for avoiding secrets is using Azure Active Directory. For instance, for Azure SQL, don't use Azure SQL Server authentication. Use an Azure Active Directory administrative account instead. If you can't avoid secrets, use Azure Key Vault. Very important, store your secrets there. Never store your secrets. Also, never store your database connection strings in some kind of configuration files, for instance. They shouldn't be there. Even if you go for a zero-trust networking approach, don't take your old legacy apps which do not fulfill all the characteristics that I told you in the last few minutes, and put them on the public internet because somebody told you that you don't need perimeter security anymore. That would not be a good idea. If you have old legacy apps and you need to run them in the cloud, you need to protect them. And you typically shut them off from access from the public internet, and you extend your existing perimeter security solution into the Azure cloud by using VPN gateways and VNets and things like that. So old legacy apps which are not ready for zero-trust networking and access from the public internet, they shouldn't be on the public internet, to make that very clear. You should also, on the other hand, avoid the traditional perimeter-focused policy for cloud-native apps. So if you have a cloud-native app which can be securely accessed through the public internet, Why put it behind bars? Why put it behind a perimeter where nobody from the outside can access these services, where your employees need complex VPN solutions to access these services? If you have cloud-native apps that support authentication, that support encryption, that do logging properly and so on, run them on the public internet. It makes your entire network configuration much simpler. It frees you from a lot of resources, and therefore, on a holistic view, it makes your entire world more secure. Avoid also forgetting logging, monitoring, and telemetry. Logging, monitoring, and telemetry is super important because, as I told you, if you live in a world of zero-trust networking, you always have to assume that someone found a hole in your security concept and is already inside of your system. And you have to find out what's going on in your system by taking a look, analyzing your logs, your telemetry data. You have to apply machine learning capabilities. And the good news is, if you use Azure Monitor, if you use application insights and so on, Azure has a lot of all these data analytics capabilities for security monitoring built in. You have to just configure it. In some cases, you don't even have to configure it. They are just there. They just do their magic, and they help you running your systems securely in a zero-trust networking environment. Don't forget that Azure Active Directory is the system for authentication, for users and for machine-to-machine authentication. So therefore, if your muscle for Azure Active Directory is not already strong, you should build a strong muscle for Azure Active Directory. You should start using it. You should start understanding it. You have to understand how to manage it, how to make it compliant and things like that, because your security concepts stands and falls with the quality of your Azure Active Directory implementation. I already talked about certificates and secrets. Yeah, and I think this one is kind of obvious. Don't invent your own security protocols and services. Use what's built in. Things like OpenID Connect, jaw tokens, and so on are super important. In a zero-trust network, you want your protocols be really secure. And if it's not your job to invent security protocols, simply don't do it. And with that, the rest of this session, I promised you, half of the session will be demo. We will switch right into demo time, and we will take a look at how private endpoints can make your Azure SQL databases more secure. I am here in my Visual Studio Code environment, and I have an Azure CLI script. For those of you who are not familiar with Azure CLI, it's essentially a bash script that is using, you see it here, the Azure CLI. This AZ command is called the Azure CLI, and with that, I'm automating the deployment of an environment, of my demo environment that I would like to show you. I would like to go into more details here and tell you a little bit of my entire environment. I'm running a Windows 10 machine here, and on this Windows 10, I run the Windows subsystem for Linux. So therefore, if I start my Windows terminal, you see that I'm here in an Ubuntu system. So I'm using Windows, but all the tools that I now run are really run in an Ubuntu system, which runs on the Windows subsystem for Linux. I also have connected a demo subscription, a Microsoft Azure subscription, and I've already authenticated on this Microsoft Azure subscription by using the AZ login statement, this one, the AZ login. I also selected my subscription because I have a lot of subscriptions behind my Azure Active Directory, and I want to use a demo subscription where I don't have any production data. So this is what I already did. If I press my short key here, I have here, you see it down there, at the integrated terminal of Visual Studio Code connected to my Windows subsystem for Linux. So therefore, all the things that I have up here, if I run it, it's run automatically down here in my Ubuntu machine. So the first thing that I would like to do in order to build my demo environment is to set a bunch of variables. They are not super interesting. I will just run it. And as you see here in the last three elements here, I also execute some AZ commands to find out certain object IDs and the tenant ID, just some things that I typically would have to copy from the Azure portal, but I don't want to use the Azure portal here because I want to be able to share this code with you and I want to automate everything. We have heard so often that we should use DevOps, and DevOps means that all we do in a repeatable way, in a documented way, and what better is repeatable and documented than having a script, checking it into Git, and being able to run it every single day again and again. Now, I created two so-called ARM templates. For those of you who are not that familiar with Azure, ARM stands for Azure Resource Manager, and they are essentially a description of my entire solution infrastructure in JSON format. And the first thing that I do here is a very simple ARM template, and it's a good way for me to describe how ARM really works. If we take a look, let me zoom in a little bit so you can see it better. If we take a look at this ARM template, you will see that we have three different areas. We have the parameter section up here. I think the name speaks for itself. I can add some parameters which I can specify when running this template. Then the second thing is I have a variable section here. This variable section is in this simple ARM template empty. We will use it later on when we create our Azure SQL database with the private endpoints and the virtual network and the subnets and so on. And down here in the resources area, I can create all my Azure resources that I would like to deploy in my resource group. In this case, I'm just creating the resource group. Yeah? So this is where I will specify that I want to create an Azure SQL database server, an Azure SQL database, and a virtual network, and all the things that I need for my demo. So remember, parameters, variables, and resources are the three aspects that we are going to talk about. There would be a fourth, outputs, here, but we will not use outputs today because this is not an in-depth discussion of ARM templates, so I will keep it simple. Okay, let's run this guy. A beautiful thing, a beautiful trick here is I can press a short key here. Let me see, Azure CLI here. Run line in terminal, run line in editor. I can use some hotkeys here. I use this one here, and with that I can just mark two lines here, and by pressing the shortcut it's run automatically here in my Ubuntu system in my Linux environment. So while this is running, let me show you the Azure portal. Here it is. Here is the Azure portal, and if I refresh this guy in a few moments, let me refresh the entire portal here. Yeah, here it is. Here is my DPS private life. This is the resource group that I just created. You see that I already created one before because at some points in my demo, I will maybe have to wait a few moments, and there I will switch to my pre-deployed version of this whole demo, so you don't need to wait until Azure is finished creating all the resources. So this is the resource group. You might ask yourself, hey Rainer, why didn't you just click on add here and use the Azure portal? It's so beautiful. I told you already that I'm working here in a typical DevOps style. And in DevOps, I don't want to create resources in this graphical UI, because if I do that, it's not repeatable and it's not automatically documented. I would like to check in everything. Every change should be documented by a pull request in a Git repository. The Azure portal is, in my point of view, a great thing to learn, to experiment. It's also great to take a look at the configurations that you have created. But if you want to use Azure professionally, you shouldn't use the Azure portal to create productive resources in your Azure subscriptions. Always use scripts like that to automate things and check them in. Okay, now we'll go to the second ARM template and take a look at this one, and this one is way more complex. I created a bunch of parameters, and I will just collapse them because it's not that interesting. I mean, we can take a quick look. You see some resource group names and so on and so on, some flags where I can specify whether I would like to deny public access. I will tell you in a second some virtual machine sizes, just some parameters. I will tell you the URL of the GitHub repository at the end of this talk, where you can download these scripts, and then you can spend quite a lot of time taking a look at the parameters. They are not that important at that point in time. The same is true for the variables. I just created a bunch of variables where I defined things like virtual network names and private endpoint subnet names and so on and so on. Not that important. The important things come down here. And let me fold all these things now, and here we will go into details and talk a lot about the different artifacts, the different resources that I deploy in this script and how they relate to private endpoints and what they do to our Azure SQL database. Maybe we start with the second one, with the Azure SQL database, because this is the Data Platform Summit, so most of you are familiar with SQL databases. Therefore, let's start here where we already feel familiar. Let's zoom in a little bit and take a look at the first part. For those of you who are not that familiar with Azure Resource Manager templates, with ARM templates, let me quickly walk you through the code. What do you see here? Some things are pretty easy to understand. Things like the name, the type. This here is defined by Microsoft. So this is the defined type, and if you want to know what's all possible to configure for a SQL server, you want to copy this thing out and just put it into Google, and it will give you a reference page from the Microsoft documentation telling you what features ARM template supports for SQL servers. So this is not an arbitrary name. This is the type as defined by Microsoft. There are API versions because over time, of course, resources like Azure SQL databases, they learn new tricks and therefore the API advances. And to make sure that nothing breaks, you specify the API version that you want to code against. And in this case, I'm using the latest preview API version. It's also part of the reference documentation. I just copied it in. Here you can specify with location where you would like to deploy your database servers. In my case, I'm using West Europe because I'm in Europe here, but yeah, you can choose any locations that you like. Now here I have my administrator login. I just use a user who is called Otto, and I'm specifying the SQL admin password here. So we have user and password here in this area. I told you before that in production, you should not use the SQL admin password like this. Instead, you should use the Azure Active Directory administrator account. And you will see a few lines below in a minute or so how you can turn on Azure Active Directory authentication for your database administration. I have an administrator login here because for this demo, in order to keep it simple and to not make it an in-depth deep dive into Azure Active Directory, I will use the administrator login password, but I want to emphasize that this is just for demo purposes. It's just because I want to focus on what's really important in this talk and not want to disturb us with Azure Active Directory details, okay? But in practice, use Azure Active Directory everywhere and avoid these passwords, okay? Important thing. Now here, this is the first thing where we have to spend a little bit of time in more details, because with this setting, public network access, we can turn on or off access to the Azure SQL database over the public internet. In my case, I made it controllable via a parameter that I can specify when calling this template. Essentially, what you typically say is you can say it is disabled or it is enabled. In the past, before private endpoints, it wouldn't make sense to say public network access disabled, because how do you want to access an Azure SQL database if not over the public internet? With private endpoints, these things have changed. You can say that you take your Azure SQL database and apply a private endpoint, and then you can disable public network access, and with that you have your microsegment, maybe your web application or your Azure machine learning stuff and so on. This is part of a virtual network, and you only want to allow access to this Azure SQL database server through this virtual network. This can be controlled with the setting public network access, true or false. The firewalls, they also are important. You probably know them from Azure SQL databases. If you don't, if you have never used Azure SQL databases before, let me tell you that Azure SQL databases have an IP-based firewall built in, so you can specify IP ranges or IP addresses which should be allowed to access your database over the public internet. Well, firewall rules only make sense if you enable public internet access. If you disable public internet access, firewall rules simply don't make any sense, and therefore I'm using a condition here. I only add some not very secure firewall rule, just for demo purposes, but I only create this firewall rule if I'm not adding the database to my virtual network by applying a private endpoint, okay? So these are the basic settings of my SQL Server. And if I scroll down a little bit, I can show you the thing that I promised you before. That is the setting, you see it here, administrator type. That is the setting with which you can control that you want to have an Azure Active Directory administrator login. In my case, I created an Azure Active Directory user, and with that, I have an SQL admin user, which is authenticated using Azure Active Directory, and if I want, multi-factor authentication. So this is the setting that you want. You would like to avoid using this password here, and you would like to go for this Active Directory administrator in practice. Again, for my demo, I will use this thing up here, but it's just for demo purposes, not for real-world applications. So this is our nice little SQL Server. I can show you this SQL Server because I already have deployed this SQL Server here. Here is the SQL Server. I've not created a database because you know what a database is. That's not the point of my talk here. And here you see I have the Azure Active Directory Administrator. Here it is. And if I take a look at the firewall settings, you will see that I have my firewall setting up here. And currently, if I go up here, the network access is not denied. So this is not a very secure setup. Well, it is a super secure setup, don't get me wrong, but it is not a setup where you limit, where you restrict access to your Azure SQL database from the public internet. So this is the usual stuff. And now I would like to go back in my script and tell you what will change once we add private endpoints. Let's fold the SQL Server here and take a look at the first section, which is the virtual network. Here you see, I'm creating a virtual network, and a virtual network is some kind of private space inside of your Azure public cloud. This virtual network can be accessible over the public internet, but it doesn't need to be accessible over the public internet. You can create so-called VPN gateways, and with these VPN gateways, you can connect your on-premises local area networks with Azure virtual networks and make the resources inside of the virtual network in Azure, including Azure SQL databases with private endpoints, to make them accessible to your clients, for instance, on your local area network. I will not go into details of VPN gateways and things like that because this is not an Azure networking talk. We want to focus on private endpoint, but it is important for me to emphasize that it's possible to completely shut off your virtual network and use a VPN to connect your LAN securely with a private area inside the public cloud. So public cloud doesn't need to be extremely public. It can if you want, but it doesn't need to. Now let us take a look at this virtual network. The first thing that you might see here are the address prefixes. The address prefixes can be something like 10.0.0.0/16. It's an IP subnet mask. It's an IP range, essentially, where you specify the IP address range of your virtual network. And in my demo, I create two subnets, and they are important for private endpoints. I create two subnets inside of my virtual network. The first subnet, the VM subnet, I will use it to create a demo virtual machine where we can interactively connect to and we can do some experiments. You will see that later on. I told you before that I'm not a big fan of infrastructure as a service and I'm not a big fan of virtual machines. Why? Because I have to manage them on my own. But for demo purposes, for learning purposes, hey, they are great. And therefore, I'm using virtual machines here in this demo. And I will put the virtual machines inside of the virtual machine subnet. It's something like 10.0.1 and something, okay? The second subnet is important. We have to create a separate subnet for private endpoints. And these private endpoint subnets need to have, you see it here, private endpoint network policies disabled, because private endpoints don't support the network policies that you might already know from virtual networks. If you don't know network policies, they are a way of controlling what comes out and what goes into your subnets, for instance. And this is not supported for private endpoints. They are supported for other subnets like here, and there are ways of still building a secure network, don't worry, but the network policies cannot be defined on the subnet where you put your private endpoints, in our case, where we put our Azure SQL database on. So don't forget, this setting here, private endpoint network policies disabled, is important. If you forget it, you will not be able later on to add private endpoints to your subnet. So don't forget it, okay? Now here you see these two subnets, and I can show you these two subnets here in my pre-deployed version of the application. Here you see the virtual network that has been created, and here you see the two subnets. If we go here, we see the two subnets. The virtual machine subnets, it's the tier 10.0.1 something, and here you see the private endpoint one with the 10.0.2.0 something, okay? That is the important one, okay? Now we have virtual networks. We have a SQL server. Now the problem is, how can we get our SQL server, which typically would run on the public internet, into our virtual network? Okay? And with that, we need a private endpoint. Let's take a look at the private endpoint here. Here you see the type is private endpoints. We have a dependency here, as to be more specific, we have two dependencies, because the private endpoints need, on the one hand side, the SQL server, and on the other hand, the virtual network. We need both, because private endpoints bring these both things together. They take the SQL server and the virtual network, and they create an IP address inside of our virtual network through which we can access our Azure SQL database locally, not over the public internet endpoint. We are going through a local IP address. But keep in mind, we are not migrating, we are not moving the Azure SQL database into our VNet. That's not the point. We are creating just an endpoint IP address, which is private to our virtual network, therefore the name. Private endpoint, but we still run the entire Azure SQL database on Microsoft's multi-tenant infrastructure. And down here in the properties area, you see the connection between the SQL server and the subnet. Here you see we specify, I have to zoom out a little bit, you will see the private endpoint subnet here. We specify the subnet where we want to have our SQL server, and we link our SQL server private endpoint name in this area. Now here, this name is somewhat important and we have to take a look at it. It's important because you cannot choose any name. It has to adhere to a certain structure, and I would like to show you this structure. Here? Oh no, sorry, I mixed something up. Forget it. This name is just an arbitrary name. I mixed something up. The important structure comes in a moment. I'm very sorry. Please bear with me, okay? So what I told you is exactly correct. We combine our private endpoint subnet with our SQL Server. Here you see the reference of the SQL Server. This is what we bring together in the private endpoint. We are still not done. These settings would be enough to create a private endpoint of our SQL Server inside of our subnet, but the problem would be that we can only access the SQL Server through its IP address. We have to deal with DNS, with domain name service, in order to be able to access the SQL Server through its name. And this is important because if we don't reconfigure DNS and if we specify the name of the SQL Server in the connection string, it would still look up the public IP address of our Azure SQL database, and later on we would like to turn off public internet access to our Azure SQL database server. So it doesn't make sense to access the public IP address. We need to find the private IP address. So what we have so far here is just the IP address. But the next point will be setting up DNS. But before we do that, I would like to trigger this deployment in the background. It will take a while, approximately 5 minutes or so. Let's run this guy. It runs in the background and we will come back to that later in a few minutes to see whether the deployment really worked, okay? And while this is running in the background, we will talk about the rest of this deployment script. Now the next ones, let me quickly open them up. The next 3 ones are related to domain name service, to DNS. We have to create 3 things. We have to create a private DNS zone. We have to create so-called virtual network links where we add the private DNS zone to our virtual network. And finally, and this is what I got mixed up previously, we have to add our private endpoint to the DNS zone so that Azure can reconfigure DNS. So that when we are in the virtual network and we ask for the IP address of our Azure SQL database server, we do no longer get the public IP address, but we get the private IP address. That is what these 3 things are all about. The first one, the private DNS zone, let me draw that one. It's really trivial. It's just creating a DNS zone with a name. Really trivial. The second one is more interesting. The second one, as I told you, connects our DNS zone with our virtual network. You see here the relation to the virtual network. This really connects the private DNS zone and tells Azure that this private DNS zone should be for our private virtual network. The most important thing, this is usual stuff if you are familiar with Azure networking, but the beautiful thing, the new thing is this one, the private DNS zone group. Because what we do here, we tell Azure that it should automatically add DNS entries for all the private endpoints that we create inside of our virtual network. And this is the important stuff here. Here we tell Azure that it should, whenever we create a private endpoint, add the private endpoint DNS entry to our private DNS zone, and therefore magically we use the private IP addresses, no longer the public IP addresses. Now we can do what I promised you before. We can take a look at one very specific thing here, and here you see it. This is the private DNS zone name and the private endpoint DNS group name, and here we have, and this one is important, private link. That's important, and SQL Server host name. Just remember this private DNS zone name. I will show you that in a second when we have deployed everything and when we take a look at how this stuff really works. Okay, so from what you should take away from this demo relating to DNS is that you should remember that you have to create 3 things in order to make this stuff work. First, create a private DNS zone. Second, connect the private DNS zone with your virtual network. Third, create a private DNS zone group in order to add private endpoints automatically to your DNS records and your DNS entries. Fine. The last things are from here on are just creating a virtual machine just for demo purposes. I add it to the same virtual network. It has nothing to do with Azure SQL Database, so I will not go into the details. If you are interested in how to create an Ubuntu virtual machine, feel free to take a look at my source code. I will share the link at the end. But I think now it is really time to take a look into the deployed resources and check whether everything works just like I told you before. Okay, so let's take a look at the deployment. Let's take a look if everything works correctly. Oh, of course, I created this virtual machine. I'm sorry, I created this virtual machine before because I don't want you to wait for my deployment. Therefore, I have a name clash here. No problem, absolutely no problem. Yeah, this is the reason why I created it 2 times. So let's take a look at this deployment and I can demo everything here. So let's take the Azure portal and take a look at the results of what we have created here. First here, you see the SQL Server, and if we take a look down here in private endpoint connections, you will see that you have this private endpoint name. This is what we created in our ARM template. And if I take a look at this private endpoint name, you will see that this is the name of our Windows server, and here comes the important SQL Server, sorry, and here is the important part. We do not access we can now, I have to put it that way, we can now access our Azure SQL Database server, the PaaS version of Azure SQL Database, not through the public IP, but through the private IP. This database server here is now accessible inside of our virtual network using this private IP address. That's the important setting from the SQL point of view. The second thing that I have created here is the virtual network. I already told you that, and I can take a look in the subnets and take a look at the subnet PE here. I already showed you that, I think. Yeah, I already showed you that before. So we can go through this quickly. Now here, you see, you have the private DNS zone. You see it here? And this is also an important one because we created this private DNS zone, and if everything worked correctly, the private DNS zone should contain, and it already does, as you can see here, a DNS entry for our SQL Server. This is the name of the SQL Server. And you see it is connected to my local IP address. Let's try that, okay? Let's go here, SQL Server, and copy the name of the SQL Server and go here in a DOS window and say NS lookup. And if I specify my SQL Server, then you will see that from my PC, this PC is not connected to my virtual network. The address is 40.68.37.158. This is the public IP address. Why do I get the public IP address? Because I'm running it here on my local machine, and this local machine is not connected to my virtual network, and therefore it does not use the private DNS zone. So if I try to access the database, and I've prepared that already, this is the database server, super secure password. If I try to access the database server here, let's run it, it works. But now we are accessing the database server over the public internet. And I will show you at the end that we can later on turn off public internet access to the database server, and then it will no longer work to access the database through this IP address. Now, I told you that for my demo, in my demo script, I do not just deploy a virtual network and a database, but I also deploy here a virtual machine for demo purposes. And here I'm already here in my Ubuntu, so let me connect. That is the wrong one, I'm sorry. This is the correct one. Exactly. This is the DPS private U6XBF and so on. And if we take a look, this is the virtual machine U6XBF and so on. So this is the correct virtual machine. And this virtual machine, in contrast to my local machine, is connected to the virtual network. So if we do a DNS investigation here, if we dig into the name, the server name here, let's take a look what's going to happen. The interesting thing is if we use this name here, then we get, you see it here, a CNAME record which redirects my SQL blah 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 server. To be honest, to be more exactly, this server here, it redirects this server to the same name but with private link inside it here. So what's happening behind the scenes, my local DNS, my private DNS zone now contains a CNAME entry which redirects the public server name to the same server name with added private link. So if I dig, you already have seen it, but I will make it very explicit here. Private link, if I dig into the same name with private link, it will tell me that I now have an A record with 10024. So whenever I run an application in Azure App Services, in Azure Container Services, in Kubernetes, in a virtual machine like this one, whenever I run an application inside the virtual network, which is connected to the private DNS zone, and I use the usual Azure SQL database name, I will no longer go through the public IP address. You have seen that here, see it here. I will no longer use this one, but I will now use the 10024 and so on. This is the IP address that I'm going to use now. What I have done on this machine is I have installed the SQL Server client tools here. As you can see it, I have SQL CMD installed here. And what should now be possible is although we point now to the local IP address, we should still be able to access our SQL Server, which is a path-based SQL Server. So I will copy exactly this SQL command statement that I had on my local machine, but this time, here it is, it should, oh sorry, yeah, this time it runs on the virtual network in the virtual machine in Azure. You don't see any difference, and that is the point. Here we access the public endpoint, and here we access the private endpoint as I've shown you through the dig command. And as a final thing, let's say the most important thing for the whole demo, I will now go into Azure, into our SQL Server, go to Firewall, and turn public network access off. This setting here, if I would do it in my script, I would have to here change false to true, but I did it now interactively, so you really see what's going on. If I turn this to disabled, and I try to access my database from my local machine, it's no longer possible. You see, access to through the public internet is no longer possible. It tells me that I have to use the private endpoint, and we can try that. Let's go into the virtual machine which is running on Ubuntu inside the VNet and try the SQL CMD there, and if everything works, we should still get an answer, and we do. So from the virtual machine, we now access the local private IP address, and everything works fine, and our SQL Server is no longer accessible over the public internet. And this is exactly what private endpoints are all about. So let's go back to the slides and quickly summarize the most important points. I would like to summarize this by recapping the next 3 slides. We started with the idea of perimeter security, and I told you why this idea of big bad internet and everything is happy inside, we are all friends, is no longer state of the art. Where we want to go to is this kind of way. This is the holy grail, this is where we want to go, but still, if we have a zero-trust networking approach, we still maybe would like to build some micro-segments where we say, hey, it should be possible to access this server over the public internet, but this server is the only one who is really accessing this server down there. So if we want to have additional security, why shouldn't we build, as I've drawn here, an additional layer of security? It just makes us more secure. So we want to turn off accessing this server over the public internet, and we just want to allow access to this database server, in our case, from this, let's say, application server. And this is where public endpoints come in. Public endpoints give us local IP addresses inside such a virtual network without relocating the server really into our virtual network. They are just creating an endpoint, an IP address, and we can use this IP address to access our resources securely through a private endpoint. I hope you have learned something, and as promised, I would like to give you the IP address where you will find the demos that I've shown here. If I scroll down a little bit, this is the GitHub repository where I gather all my samples. And here you see the Azure Private Endpoints area. And in this URL, so in this GitHub repository here, Stropek, that's my GitHub username. In this GitHub repository, you can find all my samples about private endpoints, including the sample that I've shown today. So if you want to take time and dive deeper into what I've shown you here, into my ARM templates and things like that, then go on, download the scripts from there and party on. If you have any kind of questions, or if you want to connect, I invite you to go to reinestropek.me. That's a kind of digital CV from myself. And if you scroll down, you will see a link of various links to Twitter, to LinkedIn, to my YouTube channel, where you can find a lot of additional videos for technical topics about software as a service, Azure, and so on. And I would love to see you connected in LinkedIn, Twitter, whatever, with my accounts. With that, I would like to say thank you. Thank you for listening to me. Thank you for being part of the Data Platform Summit. And I would like to say goodbye for today. And I'm looking forward to any questions that come, or to seeing you on different occasions for other locations, for other conferences in the future. Thank you, and enjoy the rest of the conference. Enjoy the rest of the day. Goodbye.